Hello everyone, for this tutorial video I like to talk about simple inductor-resistor circuits, which give similar patterns to the simple circuits investigated in the last video. If we remember from studying inductors, we know they oppose changes in their current. So if we have an inductor with no magnetic field or no charge in it, it will initially act as an open circuit, and so drop maximum voltage equal to the source. And then over time, as it charges, the current in it will increase, and so the voltage in it will decrease. And once the inductor becomes fully charged, it acts as a short circuit. So this means that it will behave in the opposite manner over time versus a capacitor. Namely, it will have maximum voltage when it's first plugged in, and then it will have minimum voltage when it becomes fully charged. Because we remember in a series circuit, the voltage across each individual component is different. This means the calculation will not be as simple as for a capacitor-resistor circuit, because you have to calculate the voltage along the resistor first, and then subtract that from the total voltage, instead of calculating the voltage of the component directly like you could with a capacitor. So in conclusion, the graph of voltage versus time for an inductor-resistor circuit will look like this, because of how an inductor works. In my next tutorial video, I like to explain how to calculate voltages and currents in specific times, as opposed to showing you the general idea / big picture in this video and the last video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.